Okay, so today we'll talk about text processing and regular expressions. So anytime you're dealing with text, especially when it's coming off the internet, things might not be formatted as nicely as you might have wished, or you might want to do variations on things. And so, regular expressions allow you to basically search for words or patterns. And so I'm sure as you guys have written a document, like an essay for another class, you're using Word or whatever it might be, and at some point you want to change the words that you're using. You might have done like Control F to do a find and replace, or you're trying to find where did I last use this word or something. And text regular expressions is basically that, except we've beefed them up to be able to find certain patterns rather than just exact word matches. Okay. However, before I get into that, I want to say something about super assignment, and that is I regret a little bit teaching you super assignment just because I think as far as the questions I've been getting about tic-tac-toe and how I've seen people use super assignment, I should have given you this strong warning and discouragement against using super assignment as part of your regular vocabulary. It's generally one of those things that you should avoid using. If you used it in your tic-tac-toe assignment and you've already turned it in or whatever, that's fine. Okay, or if you're like almost done with it and you've used it, that's fine. I'm not going to take off any points for using it, but I want to say don't get in the habit of using it. Okay? In regular old functions, the way it works, or the way they're supposed to work, is you're supposed to give everything through the arguments. Everything exists in that execution environment, and then when you're done, it returns something, and that's the only way it gets out of the execution environment. And that way, you only have to worry about the things that are given to the function through the environments. Okay, if something's acting a little bit funny, you can investigate exactly what is happening inside that execution environment, and you only have to worry about the things you've given it through the arguments. If you use super assignment to modify things in the global environment, and your function is basically changing things inside the global environment, now you have to worry about anything or everything that affects the global environment. And so rather than just keeping track of the 3 values that are passed through arguments, now you have to keep track of 20 things and 5 other functions that are also modifying things in the global environment. And so if you run into a problem or a bug or something, it's not so easy to figure out what is going on, because super assignment will kind of hide what is being modified in the global environment. It's not explicitly clear, and you also have to worry about the other things that are affecting things in the global environment, because super assignment basically says we're now messing with the global environment. So in general, it's a bad idea. There's a few times where we'll use it. So here I'm contrasting bad form versus good form. Okay, so in the bad form, you create your state vector, and then you have the update function, and this is like the simplest version of the update function that doesn't do any kind of error checking. Okay, so don't use this in your final thing, or if you did, whatever, it's fine. Here we're taking the state and we're using super assignment to update the state in the global environment. Okay, and then to run it, we just run the function update state. Okay, update state x5. Okay, and when we do this, well, let me contrast that to the good form, where here we have the state. Okay, and inside our update function, we use regular assignment. This state exists only in the execution environment, and the only way we get it out of the execution environment is through the use of the word return. Okay, and this way, to update the state in the global environment, we have to explicitly tell it, take the output of update and send it into the state that's in the global environment. And so if we encounter problems in the future, we can see, oh, this is explicitly where I am updating the state in the global environment. Okay? Whereas over here, it is not explicitly clear the change that's being made. Over here, we see we are running the update function, But if you didn't actually know what was happening inside the update function, you would not know explicitly that this is updating state in the global environment, okay? Because there's nothing about here that says that that is what is happening. It says we are taking state in as one of the arguments for the input, but it doesn't say anywhere that this is updating state in the global environment. This makes it explicitly clear that we are taking the results of update and storing them in state in the global environment. And so as far as debugging goes, this is certainly going to complicate your life because it hides what is happening, and you have to worry about the different things that could be affecting things in the global environment. Over here, you only have to worry about what's happening in these arguments because everything is stored only in the execution environment, and it only exits the execution environment through return. Okay? If there are multiple things you need to keep track of, okay, good form would be using a list. You would use a list. So let's say there's 5 things you want to update. And so it's tempting to use the super assignment and modify things in the global environment because there's 5 different things you want to update. Don't use super assignment. What you want to do is you want to create a list of those 5 things. Okay, you create a list. Maybe you want to keep track of state. Who is X, who is O, I don't know, whatever else you're keeping track of. Okay, create a list of those 3 things, and then if you want to update those things in the global environment, you would say state, and then you do update. And because update's returning a list, you would do update, and then you do $state. And if you want to do who is X, you would do update blah 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 $who is X, and that will pull out that thing from the list and store it into the global environment. But it'll be clear that you are taking the output from update and that one piece of the output and storing it in the global environment. So it's good to use lists if you need to keep track of multiple things. Otherwise, yeah. Does that make sense? This good form? Okay. I know some of you guys use super assignment. I just want to kind of discourage you and tell you to break those habits before you become dependent upon them, right? It's like you just touched your first cigarette. I would just knock it out of your hand and say, don't do that. All right. So then this is a valid question. Why did you teach us super assignment? Okay. Well, first of all, it's an important concept as far as scoping goes, right? And so scoping in environments is an important concept in R, and as far as closures go, it is part of the thing that makes R a special language. We will talk about reference classes later this week, and super assignment is useful as far as modifying values in a method for the reference class, and that's kind of one of the few exceptions. Also, there is, in functional programming, you use a function to create other functions. The thing that's being returned is other functions, and so there might be values in the function that's being returned that you want to be able to manipulate. And in that case, the super assignment allows you to have kind of basically 2 levels of parameters to be modified. The parameters inside the actual function that you want, and then maybe the parameters that define that thing, and super assignment allows you to do that. But keep in mind, even when you're doing functional programming and you have 2 levels of parameters, you are not messing with things in the global environment. You are only messing with the things in the higher scope that is still contained inside that function. Okay? You don't want to mess with things in the global environment. In general, that's not a good use for super assignment. Okay? Hadley Wickham has some thoughts on the use of super assignment. You can read them up on Stack Overflow. Everybody knows about Stack Overflow, right? And looking up for your questions about programming and stuff there. It's a great place to read up on stuff because other people have similar questions and they do that. Okay, so now we'll talk about regular expressions. We're going to use the library string R. Okay. So if you haven't done so, install packages string R, load the library. Okay. And then a lot of details on regular expressions can be found in this stringy search regex under this help thing, and also part of your homework 3's reading is to read up the on the vignette on Stringer. Okay, so this will get you started with regular expressions. So do that. So anyway, load up Stringer on your computer, and we'll take a look. So we have different functions. Okay, and so again, you can think of in your word processor, Microsoft Word or whatever, you hit Control F to do a find, and you can find the, where did you use this word? Or, you're on the browser and you're reading Wikipedia, and it's like, it's an article in the United States, so it's like super long, and you want to like find information about whatever, presidents, and you type in Control F president or something, and we'll find those locations. So what the string functions are basically, you give it, they're all kind of in this form where you give it the string that you want it to search within, and then you give it the pattern or the thing that you are looking for. Okay, string detect will give you a true false to say like, oh yeah, I found that pattern that you're looking for, that word or whatever it is that you're looking for. Locate will tell you the location where it has found that pattern. It will give you like, it'll say like, I found the pattern starting at the 452nd character in the string. Okay, if you're giving it a paragraph or something. Extract will pull out that portion of the text. Okay, match uses what we call capture groups. Okay, so it will pull out the pattern that it matches, but it will also take use of something called capture groups, which I'll explain later, and then split will take the string and then break it up into kind of a list of character vectors based on different things. Okay, there's also kind of like string detect all, string locate all, string match all, or all of this. There's an underscore all suffix to almost all of these things that will return in case it finds multiple matches or something. Okay, otherwise it generally just returns the first match it finds. So here's a little comic on regular expressions, and this is from XKCD, which is like the nerd-friendly comic. And it says, oh no, the killer must have followed her on vacation, but to find them we'd have to search through 200 megabytes of emails looking for something formatted like an address. Oh, it's hopeless. Okay, and he swings in. Everybody stand back. I know regular expressions. Ta-da. Okay. And here it says Perl, which is kind of an old language, but we can say R or whatever, Unix, Bash, all of these things support regular expressions, and they are very powerful in just getting through a whole lot of text. So here is a just simple thing. We have simple matching. This is basically the Microsoft Word find function. You type in the word, and we're going to find that exact character or string of characters. Okay, so here I'm giving it a vector of words. The quick brown fox jumps over the lazy dog, and we're going to say, do you detect the word quick? And it will say, no, but I found it in the second spot. I didn't find it anywhere else. Do you detect the letter O? And it says false, false, true for brown, true for fox, false for jumps, true for over, and true for dog. Okay. Or do you find the string ROW, and it finds it for the word brown, but nowhere else? Okay, and that seems pretty straightforward. The power of regular expressions come from what we call metacharacters, and they allow us to do special pattern matching rather than just this literal. Do you find the letters ROW together? We can say, do you find this? A class of characters. Do you find a letter followed by a number followed by another number followed by a letter or something like that? Okay, or if you want to search for addresses, you can do like, search for east or west or and followed by a number or something like that. And you can do this with metacharacters. Okay, and so if you wanted to search for the literal square bracket in this string, you can't use square bracket like this, because this will take on the meaning of the special square bracket, the meta character. So if you want to find the, and so if I did this, it will say error in string detect, it's missing the closing bracket. It doesn't like that. So you have to escape using a backslash to say I'm looking for the literal square bracket, okay? However, the backslash itself is a special character, so we have to do a double backslash, okay? So backslash square bracket will tell R to look for the literal square bracket here. All right. So because backslash is you can't use a single backslash. You have to do a double backslash, and that's going to be almost the case for all string searching in R. When you're using backslash, you're going to have to type in double backslash to indicate that it's that you're using the backslash and not the meta character here. Okay. We have anchors. Anchors indicate that you are looking for a certain pattern in a certain position. Okay. So here we are saying, I want you to start at the beginning of the string. You use either the caret or the slash capital A. And to say the end of the string, you use $, or slash Z, capital Z. You've got a little b for a word boundary, and you have slash capital B for a non-word boundary. And so this indicates kind of a position for where you are looking for these things. Okay. So here I've got a full. Oops. I have the one string. The quick brown fox jumps over the lazy dog. And here we're going to look for, we're going to replace, if it finds this pattern, replace this pattern with a dash. Okay? And because there's a caret there, it says the word the with a capital T must be at the start of the string. Okay? And so it does find that. It finds that right there. Okay? And if I say find the word dog and I put the caret here, it's not going to find a match because it will only search at the beginning of the string. Okay? So it's not going to find dog. So there's no match there. With the and the $, it says the has to appear at the end of the string, which it does not, so there's no match. Dog $, says dog has to appear at the end of the string, and it does find a match and replaces it with the dash. Okay. Caret or the slash A are the same thing. So slash A, and again we're using double backslash A to indicate that this has to happen at the beginning of the string. Okay. Double backslash A would mean quick has to appear at the beginning of the string, so there's no match. And double slash Z or slash Z is at the end of the string, so there is a match for dog. Dog slash Z. The slash B means word boundary. And so this means find the letters JUMPS, jumps, but it has to be preceded by a word boundary and followed by a word boundary. So basically a word boundary means like a space or a new line character or something to indicate that the word has ended. And so here it's going to find jumps and finds it. Okay. However, if I say jump without the S and say it has to be preceded by a word boundary here, JUMP, followed by a word boundary, this is not going to match because here it finds JUMP, but there's an S and not a word boundary, so it's not going to match there. Okay, because there's something that's other than a word boundary. The capital B is a non-word boundary. Okay, so in general, there's kind of this pattern where you have this class of character like a word boundary or a digit or a space or something, and you use the little letter to indicate that that's what it is, and you use the capital letter to indicate you don't want that thing. Okay, so non-word boundary would be capital B, and so here it says find the letters UMP, but it cannot have a word boundary in front or a word boundary after, and so it finds it right here and replace the UMP with a dash. This because J is preceded by a word boundary, and we're saying we don't want a word boundary over here. There's no match. Is that good? So those are word boundaries, and so you can make sure you're getting like complete words, or make sure you're not getting the something in the middle of the word, or you are getting something in the middle of the word. Okay, we have character classes. /s is for white space, so that's a space, also a non-breaking space. I don't know if you guys are familiar with breaking versus non-breaking spaces. So generally, when you type in a word processor and you say like, my name is Miles and I'm teaching statistics or something, and it reaches the end of the line and it says like, oh, you've got teaching space statistics. Statistics isn't going to fit, so I'm going to bring the word statistics onto the next line, okay? And that's because the space there is called a breaking space, meaning you can split these things apart, right? Let's say, for whatever reason, you wanted to write UCLA, but with spaces. So you wanted U space C space L space A, okay? But you don't want it to break across two lines. You don't want like UCL and then the A to appear down here. So what you can do is you can create non-breaking spaces, okay? Which basically is like an invisible character, and it treats it as one word. So even though it looks like U space C space L space A, it's going to treat the spaces in between there as non-breaking spaces, so that that thing appears as one word, and so the whole thing will move together onto the next line rather than breaking it across where there's a space, okay? Yes?
So the word boundary that you talked about in the previous slide is the space between them.
Yeah, it's a breaking space, yeah. Okay? So a non-breaking space, but the only unfortunate thing is when you go online, your eyes can't tell between a space and a non-breaking space unless you look at the underlying code, okay? And so there is a part in your homework 3 where you non-breaking spaces are going to cause problems, okay? And so I've given you code in homework 3 that tells you how to get rid of the non-breaking spaces, and it basically says search for /s and replace it with just a regular old space, okay? Capital S is non-white space, okay? And then you've got /d versus capital D for digits or non-digits, digits being 0 through 9. And then you got /w for words. Word characters would be the capital letters, lowercase letters, the digits 0 through 9, or underscore. Okay, so it's kind of like anything that would be part of like a file name or something like that. Okay, and for whatever reason, this did not appear on the next line. Capital W /W is a non-word. Okay, so sorry, that should be on the next line there. You can also give it ranges of characters. Okay. We have the dot. The dot is like any character. It's like the wild card, okay? Any character except a new line character. If you use a square bracket, this will be a range, okay? So this says match one letter that is either an A, a B, or a C, okay? It's not saying match the string ABC. It's saying match one character that is either an A, a B, or a C. Here it says match one character that is not an A, B, or C. Over here we're saying match any of the lowercase letters A through Q, or match any of the uppercase letters A through Q. Okay? But again, just one letter. And here we've got the digits 0 through 7. So these are ranges. Ranges of characters. So let's say I have these words, the fox, the lazy dog, theater, and Prometheus. And I'm saying find the string THE. Okay? So here it doesn't find it over here because it's got a capital T. So it's case sensitive. It's not going to find the little lowercase the is not going to match capital the. Okay? Of course it doesn't match fox. It matches the, not lazy or dog. It will match theater. It matches the in theater, and it matches the or THE in Prometheus. Okay. Over here I've given it square bracket THE. So this says match one letter, and if you find a match, return the first thing you find. That's either a T, H, or an E. So in this case, it says, I found the letter H, so it returns that. Here it says I found the letter T in the, In theater, it says I found the letter T in theater. And for Prometheus, the first one it finds is the E right here. And so it's going to return the E in Prometheus. Is that okay? And so again, it's just saying find one letter that matches either T, H, or E. And return the first one. We have quantifiers. Star says find 0 or more of these things, where a plus says find 1 or more. Okay? So star says find this or not. Okay, it's optional whether you match this. Plus says you must match at least 1 or more of this character. And the question mark says either match 0 or 1 of these. Okay? Curly brace 3 says match exactly 3 of these letters. Curly brace 3 comma says match 3 or more. And curly brace 3 comma 5 says match 3, 4, or 5. Anything between 3 to 5. So you can put numbers in curly braces and it'll match that many. So here I've created some more words. The, theater, Prometheus, TZZE, and TZZHZZ. Okay? And here we're going to say square bracket, THE, curly brace 2. So this says find a letter in TH or E and find 2 of those. And find 2 of those together. So in this case, it goes to the, and it finds the H, and it also finds the E. So it returns that. In the little the, it finds the T, and it finds the H, and it says, okay, well, I found 2, and that was the first thing, so it stops there. Same thing with theater, it finds the T and the H, okay? For Prometheus, it will find this E and this T, and it will match that, okay? Over here, it finds the T, but it's not followed by an H or TH or E, so it finds no match. And over here, it finds the T again. It's not followed by a TH or E, but it finds an H, which is followed by another H. Okay, so that satisfies the pattern of THE and 2 of those characters. So it will match the HH. Is that okay? What's happening here? Okay, we have greedy versus ungreedy matching. Okay, and so here is this kind of like a little piece that I've pulled out from a hypothetical HTML code or something. And here what we want to find is a div tag, okay? Dot represents wild character, any character, and star represents 0 or more. So dot star is kind of like this wild everything. So dot star will match pretty much every single thing, 0 or more of any character. And so, so that's kind of like the all-inclusive one. And the greater than, less than signs are not meta characters, so and the forward slash is also not a non-meta character, and so it will match these literals. Okay. Greedy says grab as much as you can. Okay, especially with the dot star, it's going to grab as much as you can. So it's going to find this div, it's going to find this div tag, and start there, and it goes okay, and we're going to stop when we find a closing div tag. It sees a closing div tag here and another closing div tag here, okay? With greedy matching, it's going to say, I'm going to get as much as I can, and it goes to the last closing div tag. With ungreedy matching, you give it a little question mark to say, don't be so greedy. It's going to stop when it finds the first closing div tag, okay? It's going to try to find the smallest version of this matching pattern, whereas the greedy one is going to find the biggest version of the matching pattern. Okay, so with the greedy matching, we get both closing div tags. With the ungreedy matching, we only get one closing div tag, or the first closing div tag. Okay, and now we can talk about capture groups. Capture groups are useful when you use string match and string match all. We're going to match the text ABCD and capture the text in the group BC. We put these parentheses around BC, okay? And so what this says is, first you've got to match this whole thing. You've got to match everything in the pattern, A, B, C, D, okay? But the part that we're interested in is not the whole pattern, but just this one portion of it, okay? Which in this case is what's inside the parentheses, okay? A non-capture group, you put the question mark colon to say, we're going to group this, but I don't want it, okay? And here, again, you can have multiple capture groups. So we're just going to say, match this entire pattern, A, B, C, D, E, F, G, H, I, but the only parts that we're interested in are these, what's in the capture groups, the A, B, C, and the G, H, I, okay? And then you have back references to say, like, remember that thing you captured? I want to use part of that. And you can back reference 1 to 9, saying up to like, or you can even go up to 99, and you can have like 99 different capture groups within a string. That's quite complex in my opinion, but it can be done. Okay, so here we have the text A, B, C, D, E, F, G, H, I, J, K, and here it says match the pattern. The pattern is A, B, C, D with a capture group around B and C. So extract is just going to pull out the matching pattern. The match will pull out the pattern that matches, and then it extracts the capture group separately. So you get A, B, C, D, and it says, remember that thing that capture group? I've pulled it out over here. Same thing with this. It's going to match the entire pattern, and it pulls out, or it matches the capture groups, A, B, C, and G, H, I in this case. Let me, okay. Let me clear this out here. Okay, so here, let me show this here. So here we've got just some pretend text, testing, emphasized text, and back in the day with HTML, you would italicize things using I, and you would make things bold using the B tags, okay? Today, they recommend using M tags or strong tags for emphasis or making things bold and things like that. And so let's say we wanted to replace this, okay? So here's kind of the text string that we want. Let's say I want to just pull out what's in between these tags here, okay? So the pattern I can make is this. This says match, make sure you start with a less than, and then either a capital B or I character, and then a greater than sign. Okay, so that's going to match right there or right there. Okay, what does this say? /W is word character, right? So either capital or lowercase letters or digits or underscores. Word character, and what does the plus mean? One or more. So this will match the entire word emphasized, okay? Or this emphasized here. I put it inside the parentheses to say this is a capture group, meaning I want you to pull this out and treat it separately from the rest of the pattern, okay? And then and then we're going to have the closing tag, which will have the slash, /, and these are non-meta characters. This part is, and so either a B or an I. So I can say string extract, and we want text1, and we're going to use the pattern. Okay, and so, whoops, not text1, text in the pattern. And so this is the pattern it matched or extracted. And if I do match, it will respect the capture group, and it says, okay, I've found this thing, and I've extracted that part in there, emphasized. Okay, what if I, and here I can do the same thing with the second text, and it says, okay, I found it with the B's, and I've pulled out that word emphasized. Okay, I can run the replace, str_replace, and I can say take text, the original text, and use the pattern, and the thing I want you to replace it with is I want you to use the emphasis tag, okay, and put in the word that you found here, okay, the first thing in that first capture group. And so to say put in that word emphasize, we're going to put in //1, and we're going to close it off, okay? And so this will take whatever is in this capture group and stick it right there. And so it replaces testing emphasize the I's, and it will replace it with the M tags here. Okay, or you can say like do it twice, okay, and then it'll do like emphasized, like right after each other or something. Okay, I mean that's kind of silly, but you can do it that way. What would happen if my first thing was instead of emphasized, I did italic stuff text? Okay. Will this match? The match pattern I'm leaving the same, / W and this. Okay, it says it doesn't match. What's the problem here? So just to remind you, my pattern is this. So what's the problem with this pattern trying to match testing italic stuff text? The problem is I've got a space here, okay, and the space doesn't count as a word. So I have to modify my pattern, okay, by saying I want either a word thing or a space, okay? So I'm putting it inside the square brace to say I'm happy if you see a word or a space character, okay, by putting it inside the square brace. And this will say I still want one or more of those, and it still keep that inside the capture group. So this will be my pattern, and then so now if I match the pattern, here's italic stuff, and it matches italic stuff here. Okay, and then we can run the same thing, replace the bold, and if I did //1, or let me even put this, it's going to replace emphasis, and then it's taking italic stuff and it's putting it in there twice. Yeah, question?
When you do the match, why is it only returning emphasized for the capture group and not the backslash or the B tag?
Wait, the /1? Or the
match, for string match.
String? So it does. So it says I found this is the entire part that matched, okay? But because only this part is inside the parentheses stuff, which does not include the B or the I, and just the word, or actually I modified it. I'm sorry. This is the pattern here with a word or stuff space. It only matches that. Okay, so it pulls out what was inside the parentheses. Let me just show you another example. So here I've got a vector of character vector, Apple, some phone numbers here, 219733, this and this. Okay, this one has spaces here. This one's dashes. This one has dashes, and this one has dots. Okay, and so here we're saying match this pattern. Okay, and I think actually I should have escaped this the dot here. And so here we're saying we want a capture group by putting parentheses here. And here it says I want a number between 2 through 9 because the first number of an area code is not going to be a 0 or 1. Okay, so I want one number between 2 through 9 followed by two numbers that are 0 through 9. Okay, by saying curly brace 2. Then take any grouping of 3 digits, so any digit character, but there needs to be 3 of them. Put that in another capture group. And another set of digits of 4, put that in capture group. Between them, we're going to accept a dash, a space, or a dot. A dash, a space, or a dot. And I think I should have actually escaped the dot to say a literal dot. I think this is actually just a wild thing. Okay, so we're going to say string extract, and so here it says I didn't find a match with Apple. I found a match with this thing. I found a match with this thing. And over with this one where we got 2 phone numbers in the same thing, it just finds a match against the first one. That's going to be string extract. I can do string extract underscore all, and it's the same text as before. Finds no match with the first, and it finds a match here, and it finds a match here. And then for the last one, string extract all says you might find multiple matches and return back all of the matches that you find. So it says, okay, I found a match here with the work number. I also found another match with the home number. Okay, and it will return both of them. Because you can have some of the strings are going to have no matches, some will have one, and some will have more than that. It returns it in the form of a list. So if you want to deal with this, you're going to have to unlist it or do some kind of change to it. Okay, because string extract all is going to return things in the form of a list because it might return more than one for some and only one or none for others. So that's string extract all. Yeah.
So for the first form pattern, they require for 2 numbers or 3 numbers?
It requires 3 numbers. Okay, it's saying one digit, the first digit, the leading digit has to be between a 2 through 9. It can't be a 0 or 1 because at least in the U.S., your phone numbers, your area code is not going to start with a 0 or 1 because those are used to indicate I'm making a long distance call or international call or something like that. So the first one, okay, so this says one digit that's between 2 through 9, another digit that's between 0 through 9, but there's 2 of them. So this is still 3 digits right here. String match takes the same thing and it respects the capture groups. So the first capture group is basically the area code. This is, I think, the prefix and the suffix or whatever you call it, okay, to say the next group of 3 and the next group of 4. Okay, and then match all, again, with string match, it only finds the first match and it returns that. With a match all, it will say, okay, some of these I can return 2 things here, okay, because there were 2 numbers in that string that matched it. So in your homework 3, first you're going to use rvest to pull things out of this table, and then the last part is to use regular expressions to pull out from one column. There's a manager's column which shows information as text, okay, and you're going to want to extract the manager name, the number of games the manager won, and the number of games the manager lost. Oh, and by the way, in baseball, the coach is called the manager, okay? Like every other team, they call it the coach, but in baseball, they're called the manager, okay? And so as far as this goes, you're going to want to use string match all, okay? Because most of the seasons, you'll have one coach or one manager for the entire season. But sometimes, and there's 162 games in a season, so there's lots of games, and sometimes the manager will get sick, or there will be 2 different managers in the same season, or multiple managers. And so match all will allow for having different numbers of managers in the same field. Okay, but you're going to be getting a list back, and you're going to have to kind of unlist it or modify things, rbind list or something to do that. You'll have to figure out what the correct regular expression text would be to pull out the pieces of information that you want. Okay, I think it's good practice here, and I hope you enjoy the homework assignment. But that's my hope every time. I was hoping you would enjoy tic-tac-toe as well. Here are some extra resources to read up on regular expressions. They are very, very powerful, and if you know regular expressions, you can do a whole lot of stuff with your computer.